Hey everyone, welcome back and let's write some more neat code today. So today let's solve the problem special array 1. It always feels really weird after we get done solving some hard problems to be given like an easy problem. I'm not gonna lie, like this one is pretty easy, I think for most of us, but I know that there might be like some beginners watching this, and if you're a beginner, it might not necessarily be easy for you, but yeah, anyways, let's get into it. So the idea is that we are given an array of elements. Let me use the second example. We want to determine if the input array is considered special or not. We know that the array is special if every adjacent pair of elements, so basically like this pair of elements is adjacent, this pair of elements is adjacent. If we had more elements, we would kind of just keep doing that length to window. And what we want to know is that every adjacent pair of elements has a different parity. Probably the only question in your mind is, if you're watching this video, what does parity even mean? And they kind of explain it, I think, in one of the other examples, but I'll just tell you, basically, if one of the elements is even, then the other one has to be odd. We cannot have two consecutive elements that are both odd or that are both even. So if this were the case, two adjacent odd elements, we would return false. If we had two adjacent even elements, we would return false. If we go through the entire input array and neither of those happen to be the case, finally at that point, we would return true. So knowing that, we can solve the problem pretty easily. Just compare every adjacent pair of elements. The way I'm going to do this is by having an I pointer. It's not going to start at 0. It's actually going to start at 1. It's going to go up until the end of the array. We're always going to compare this element with the previous element. And what we're specifically going to do is just take this number, mod it by 2, we're going to get 0. Take this number, mod it by 2, we're going to get 1. These are not equal. That's good. We continue. We always expect them to not be equal. If they were ever equal, then we would return false. That's not the case right now. We look at the next pair, again, not equal. We keep going. Another way to think about it, I guess, would be the binary representation of this number is going to be 0. The binary representation of this is going to be this. What we really care about is that there are no two adjacent elements that have the same bit set in this position. Now, imagine if I had like an 8 over here. 8 in binary will look like this. So in this example, neither of them has the bit set. So basically, they should have a different bit in this position. And if we had two even elements that are adjacent, at that point, we would return false. If that didn't exist, then we would reach the end of the input array here and then return true. So now let's code it up. So I'm just going to iterate over the input array nums, well, starting at index 1 and then going up until the end of it. And what I'm going to check is specifically this. The number at index I, I'm going to either mod it by 2 or bitwise and it with 1. Those are both pretty much equivalent. And if that's equal to nums of I minus 1, again, I could do this as this way, or I could do it this way. It'll give me the same thing either way. At that point, I would return false. If that never happens out here, I can return true. Let me run this. I'm not 100% sure if I need to wrap this and this in parentheses, but let's just run it and try. Okay, it looks like it works. It's pretty efficient. If you found this helpful, check out Leetcode.io for a lot more. Thanks for watching, and I'll see you soon.